Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Chapter some basic principles and techniques in organic chemistry, and we are doing the representation of the electron movement in the organic reaction. Hello friends, now we are discussing about the representation of the electron movement that takes place in the organic reaction. So in the previous lecture we have studied about the mechanism of the organic reaction, and in that case we have got to know that during the mechanism or during the reaction of a reactant, the bond formation as well as the bond breaking takes place. But this bond breaking and bond forming are being showcased by the representation that is known by the electron movement, and that is what we are going to discuss about. So what are those? Let us talk about it. So now we are doing the representation of the electron movement that takes place in organic reaction. So now we know that in an organic reaction, the curved arrows are used to show the movement of electrons. Yes, this plays a very vital role in giving the mechanism of a particular reaction also. So therefore, in every reaction or in most of the case, when we represented the mechanism, represent the mechanism. So in that case, we have to represent the arrows, and this arrows indicates the movement of the electron that takes place from one bond to the another one. So there are different kind of the representation that we are going to talk about, but let us discuss the detail what are this representation are about. So talking about the next one, that is, so the curved arrows is a convenient notation to show the change in bonding due to electronic redistribution during a reaction. So whenever a electron redistribution takes place while forming from one bond to another bond, so we have to represent it. So for representation we use curved arrows. So that's the reason that this curved arrows plays a very important role in understanding that how the reaction has been occurred and how the electrons has been moved from one form to another form or from one bond to a particular atom. So that's the reason that this curved arrows plays a very convenient role. And talking about the next one, that is, a covalent bond is formed by sharing a pair of electrons between two atoms. So this is what we know. So a covalent bond is formed because of the sharing of the two electrons, but even this two shared electrons or this pair of electrons that we are talking about, even that can be shifted, or we could say even the electron movement can take place in that case. So that's the reason that whenever we represent a curved arrow, we represent a curved arrow when and a pair of electron is being shifted to a particular atom, or when a pair of electron is being shifted to another between the two atoms that are being present. So that is the reason there are three different kind of method that we are going to talk about. So starting with the first one, that is shifting of an electron pair from pi bond to an adjacent position. So let me give you an idea that how can we represent this one. Suppose this is a bond that has been, as you could see, that this is a covalent bond that you could see. Then among this, one is the pi bond over here, as you could see over here, because one of this bond would be a sigma bond, while the other one would be a pi bond. And this bond, as you could see, this is a sigma bond itself. So as we are discussing about that, there should be a shifting of electron pair from pi bond to an adjacent position. So therefore, this is a pi bond that we could see. And even this pi bond is compromised, or it is made up of the two electrons, as we could see over here. So if it has to shift from one bond or from one side to another one, then we will use it curved arrows. So therefore the curved arrows are being represented in this way. So once this curved arrow we have represented it, then this one would have been converted into this form, as you could see over here. That is, so this sigma was present already, and even this sigma was present already here. So therefore I will make a note on that also. But meanwhile, the pi bond has been shifted to the adjacent position. So that is the reason that there would be a pi bond that would be developed between in this position, as you could see. So therefore this curved arrows represent the shifting of the pi electrons from one side to other side, or from one position to another position, as you could see over here. So this is what I want to talk about. And so this is not the single possibility, there are various possibilities, and this is the thing that we are going to use or that would be very much helpful in understanding a mechanism of a reaction, because in mechanism of a reaction we usually represent the shifting of the electrons by this curved arrows only, and this curved arrow represents that the electrons has been shifted from one position to another position. And now let us talk about the another one, that is the another possibility so as to represent, that is shifting of an electron pair from pi bond to adjacent atom. So let me give an idea about that also. Suppose again the same thing that I have represented over here, like this one. So here are the covalent bonds that you could see that this one is a pi bond, sigma bond that we could see over here. Even this one would be the sigma bond, while this one would be the pi bond. And each bond is being made up of 2 electrons. So therefore, even this is made up of 2 electrons over here. Again, this are made up each bond is made up of 2 electrons. So what we have to do is we have to shift the electron pair, that is this pair that we could see over here. So we have to shift this electron pair, which is nothing but a pi bond, to an adjacent atom. So therefore this is the adjacent atom that we could see over here. So therefore the representation should be in such a way that the pi electron should be end on this atom. So in the previous one, as we could see, that the pi bond has been shifted to this position. So therefore this, from where the originally the pi bond that was been present, so it has been shifted to this position, that is it has shifted to another bond. So as you could see over here, that is this is the position where sigma and pi bond were been present. But after the shifting of electron, we could see that the pi bond has been shifted above that of the sigma bond. So therefore it has been shifted in this case. And talking about this case, that is the second one. So in this case, what we have to do is we have to shift the electrons on the atom. So in this case, the adjacent atom is nothing but the Z, as you could see over here. So that's the reason after the process has been occurred, we could see that the electrons, because it is a pair of electrons, so therefore the both electron that will be accommodated on the atom in this way, as we could see. That is this 2 electrons, because this pi electrons was being made up of 2 electrons, as we could see over here, and that's the reason it has occupied a pair of electron on the atom. So even this is a kind of possibility that we showcase, and moreover we could see that these 2 electrons are being because the presence of 2 electrons makes it a negative charge, so therefore we could write it over here as a negative charge over here. So this was the second possibility, and now let us move on to the third one, that is shifting of an electron pair from an atom to the adjacent bond. So this was an example where the pi bond has been, or the pi electrons have been shifted on the atom, and this is what we could see, that the electron pair was on a particular atom. And now this electron pair can also be shifted to the another position. So that is what we have to show. And so there are different possibilities that we are mentioning about. So therefore, suppose if we have, suppose that is electron pair that is present on an atom, that is this one. So this is an electron pair that it has, and what we have to do is we have to shift it. We have to shift it to the adjacent bond position. So therefore, for shifting, we should represent it again with a curve arrow. So that's the reason that we will represent it with a curve arrow, because this electrons are being shifted to the adjacent position. So therefore, we are pointing it to the position where a bond is being present. So now here the sigma bond is being present. Here also the sigma bond is present. But because of these 2 electrons that are being on the atom, and they are basically the pi electrons, so that's the reason that the bond that would be formed, so the new bond that would be formed is basically the pi bond. So that's the reason we could write it in this way, where this one, where the sigma bond that were already present over here, and this is the new bond that has taken place over here, and which is nothing but the pi bond. So this is what we represent, and this is the representation of the electron movement. So these were the 3 important things for the electron movement. So here we have talked about the shifting of the covalent bond in terms of an electron or pair of electron, we could say, but it is not necessary that the electron shift would takes place in this manner only. So for example, there would be also a possibility of a formation of distribution of this pair of electrons. So let me talk about this one. Suppose if we have a reactant, or suppose if we have a molecule like this one, as you could see. So this bond is made up of 2 electrons. So in earlier cases, we have seen that the pair of electrons, they will shift on either atom or it will shift on the adjacent bond. But what if the bond breaks? Suppose if this electron and this electron, they both are being occupied because of, suppose this electron which is of the A and this electron which is of B, suppose if the bond breaks in such a manner that the A gets its own electron while the B gets its own electron, and there will be no bond formation. So therefore that kind of bond fusion that takes place is basically known as homolytic fusion, and will talk about what is homolytic fusion. And so suppose if the bond breaks, so we could see that this bond, even electron has to be shifted, and we always shift the electron from the bond to the atom, or from the electron to a particular position where a bond could take place. So therefore we could see that this is something basically known as fish hook. So this indicates that the electrons are being occupied on that particular atom. So in this case what we could see is this A has occupied its electron plus the B has occupied its electron. So earlier it was basically the shifting of the electron pair, but here there is shifting of electrons. So therefore the bond which used to be formed because of the two electrons or electron pair, now after the homolytic fusion they have shifted in this manner. So even this is a representation, but this fish hook represents that the one electron, not the electron pair, only one electron that has been shifted from a bond to a particular atom. So therefore this is also a representation that I was talking about. So thank you friends for watching this video. So here we have discussed about the various electron movement of that could take place in an organic reaction, and I hope you have understood this concept very clearly and you will share this video with your friends, and just don't forget to subscribe Ekeeda channel. Thank you so much.